Welcome to Water Mission's video series on the Grundfos Renewable Solar Inverter, or RSI. This video covers the important topic of setting the minimum and maximum frequencies at which your pump can operate, including why do we need to set the minimum and maximum frequencies, setting the minimum frequency, setting the maximum frequency, and verifying the settings. First, let's discuss why the minimum and maximum frequencies are important. The minimum frequency set point helps protect the pump. Water moving between the pump motor surface and the borehole casing or pump sleeve wall cools the motor. A certain water velocity is needed to provide adequate cooling corresponding to a minimum frequency. Operating at or above this minimum frequency also increases the lubrication of the bearings and decreases vibration and mechanical wear. The maximum frequency set point helps protect the water source. A yield test should be done on each borehole to ensure that the pump is not being overdrawn and that the desired pumping rate is sustainable with the well recovery rate. If you are using the Water Mission Pump Design Tool, the minimum and maximum frequencies are calculated based on assessments and design and can be found in Step 5. For projects not utilizing the Water Mission Pump Design Tool, the minimum frequency recommended by Grundfos is 30 Hz. In the example for this video, the calculated minimum frequency for cooling velocity is 31 Hz or 3.84 meters cubed per hour. The maximum frequency typically corresponds to around 80% of the allowable borehole yield. In some contexts, for example when serving refugee populations, the allowable yield may be up to 100%, as in this example where the maximum allowable yield is 6.36 meters cubed per hour, corresponding to a maximum frequency of 60 Hz. After completing the startup wizard, Water Mission recommends entering the calculated minimum and maximum frequencies into the quick setup menu just in case the full minimum and maximum frequency setting process cannot be completed in the initial startup. It is recommended, however, to complete the full process as soon as possible. To set the calculated minimum and maximum frequencies, press Home, Main menu, Quick Setup, scroll down and select Min Freq Reference, select Edit, use the arrow keys to adjust the frequency to the calculated frequency from the Water Mission Pump Design Tool, which in this case is 31 Hz. Press OK to save, press back, scroll down and select Max Freq Reference, select Edit, use the arrow keys to adjust the frequency to the calculated maximum frequency from the Water Mission Pump Design Tool if needed. In this case, we will leave it at 60 Hz. Make sure to press OK to save if you change the value. Next, let's discuss how to do the full process of setting the actual minimum frequency for the operational project. In this step, we are empirically identifying the required minimum frequency setting rather than relying on the calculated value because these may not align in some projects. The goal is to set the RSI minimum frequency to the value that corresponds with the identified minimum cooling flow rate, which in our example is 3.84 meters cubed per hour. The calculated corresponding frequency may or may not be the actual required frequency at the project site. To do this, we will open the program integrated into the Grundfos RSI made for this purpose. Press Home, scroll up to and select Set Min Frequency, read the instructions and press OK to start. You can adjust the starting frequency as desired, then press On to start the pump. We will start with 30 Hz to be conservative. Pump will then start running at 30 Hz. A 1-minute water test must be conducted at each frequency tested until the frequency corresponding to the desired minimum cooling flow rate is identified, in our case, 3.84 meters cubed per hour. With the pump running at a known frequency, in this case, 30 Hz, look at the water meter and identify an upcoming value as the meter is reading and make note of it. For example, 217,400 liters. Right when the meter hits that exact value, start a timer for 1 minute. Then note the water meter reading when the time reaches exactly 1 minute, for example, 217,458 liters. Determine the volume of water pumped in water meter units, in this case 58 liters per minute, since our water meter reads liters. Convert that volume to meters cubed per hour, which in our example is 3.48 meters cubed per hour. Since we need to reach 3.84 meters cubed per hour, the frequency must be increased to increase our pumping rate. Go to the RSI and increase the frequency within the set min frequency program 1 or 2 Hz and repeat the 1 minute water meter test, making notes of the flow rate at each frequency until you reach the required minimum cooling velocity. At 31 Hz, the flow rate was 3.6 meters cubed per hour, so we need to increase the frequency and repeat the 1 minute water meter test till we reach 3.84 meters cubed per hour. Increase the RSI to 32 Hz. Repeat the 1 minute water meter test. At 32 Hz, the flow rate is 3.72 meters cubed per hour. We're getting closer, let's keep going. Increase the Hertz to 33 Hz. Do another 1 minute water test. At 33 Hz, we have reached the 3.84 meters cubed per hour, which is our minimum cooling flow rate. So the actual minimum RSI frequency for this project is 33 Hz rather than the calculated 31 Hz. Press OK within the set min frequency program at the desired frequency. Select yes to save the minimum frequency, then press OK to exit the program. Make sure to note any differences between the calculated and empirical minimum frequency values. Next, let's discuss how to set the maximum frequency for the pump. We've identified that the maximum allowable yield is 6.36 meters cubed per hour, which theoretically corresponds to a calculated 60 Hz from the Water Mission pump design tool. 60 Hz is also the maximum frequency from the pump and RSI specifications. Start the pump and let it reach the calculated maximum frequency you've already programmed into the RSI, which in our example is 60 Hz. Then take a 1 minute water meter test. You may notice that your water meter is spinning faster than before since the flow rate is faster at a higher frequency. At 60 Hz, we are seeing 6.66 meters cubed per hour when our maximum allowable yield is only 6.36 meters cubed per hour. Gradually decrease the frequency and repeat the 1 minute water meter test at each interval until the allowable yield is reached. To decrease the frequency, press Home, Main Menu, Quick Setup, and again scroll down and select Max Freq Reference. Select Edit. Decrease the frequency with the arrow keys 1 or 2 Hz. For this example, we will try 58 Hz as the new value. Press OK to save, and your pump should be running at 58 Hz. Take another 1 minute water meter reading. At 58 Hz, we are at 6.6 meters cubed per hour, so we need to decrease again to reach 6.36 meters cubed per hour. Decrease the frequency again using the same method within the Quick Setup menu. This time we will try 56 Hz, after which your pump should be operating at 56 Hz. Take another 1 minute water meter reading. At 56 Hz, we are at 6.36 meters cubed per hour, which is the maximum allowable yield for this borehole, so the maximum frequency for this project is 56 Hz. It is a good idea to go back into the Quick Setup menu to make sure that both your minimum and maximum frequencies are still set as expected. Finally, it is a good idea to verify the settings to make sure that the pump operational frequency stays within the minimum and maximum settings that have been programmed. To do this, run the pump under a variety of solar and AC conditions to get the full frequency range. This could be solar at low light conditions to check the minimum frequency, as well as full sun or AC power to check the maximum frequency. As previously mentioned, it is important that the pump operate within these set points to ensure proper cooling and to make sure the borehole is not being overdrawn. Thanks for watching this video on how to set minimum and maximum frequencies for your project with the Grundfos RSI. Make sure to check out Water Mission's other Grundfos RSI training videos.